Welcome back, everyone. If you've glanced at the tech industry lately, you've probably noticed that data and AI roles are mutating at literally the speed of light. Data is everywhere, right? And AI is completely reshaping it. But who actually does what? In today's Explainer, we're going to walk up the evolutionary tech ladder. We'll break down the exact skills, the tools, and the distinct value of these core roles. Okay, let's dive into this. Here is our roadmap for today. First, decoding the data landscape. Then, comparing business and data analysts. Third, the data scientist. Fourth, engineering AI with ML and Gen AI. And finally, finding your perfect role. All right, part one, decoding the data landscape. Let's break this down logically because I know the tech ecosystem can be pretty intimidating.
And this brilliantly illustrates the entire terrain we're going to explore. We're looking at a complete roadmap of data careers, which are segmented into 5 very distinct roles. You've got the data analyst, data scientist, business analyst, ML engineer, and the Gen AI engineer. Now, each one of these speaks a completely different language, but they all extract massive value from information. Let's zoom in and look a bit closer at the foundation.
Part 2, analysts, business versus data. These are the first logical pair in our tech ladder. Now, what's really interesting about this slide is the clear contrast in skill sets. On the left, we have the business analyst. Think of them as our translator. Their core skills are highly structural and superhuman-centric, things like gathering requirements, communication, and process modeling. On the right side, though, we have the data analyst, our detective. They rely heavily on SQL, Excel, and basic statistics to really dig into the numbers and figure out what they actually mean. A data analyst might even dabble a bit in Python. And naturally, because their skills are so different, their toolkits diverge completely. If you're someone who prefers talking to people and solving high-level business problems, the business analyst toolset is definitely your sweet spot. Alongside Excel and BI tools, they basically live in Jira and Confluence. Those are absolutely crucial tools for translating abstract business needs into documented, actionable sprints for the engineering team. Yes, but what about the data analyst? Well, they do share Excel and visualization tools like Power BI and Tableau with the business analyst for sure. But instead of project management software, their absolute primary weapon is SQL. They focus purely on querying the database directly. They use SQL to pull that raw information, and then they use Tableau or Power BI to visualize it. Essentially, their main job is to tell the business exactly what happened in the past. Moving on to part 3, the data scientist. So, the data analyst tells you exactly what happened in the past. Yes, but who tells you what will happen next? Answer the data scientist. If the analyst is the detective, the data scientist is the fortune teller. Notice the major skill upgrade here. We're stepping up from basic stats to advanced probability, heavy Python or R programming, and we're introducing things like machine learning, data wrangling, and feature engineering to build real predictive models. To build those awesome predictive models, they obviously need a highly specialized toolkit. While they still visualize data with Tableau, their world really revolves around Python libraries. Think pandas and scikit-learn for machine learning. And they do almost all of this complex modeling inside Jupyter Notebooks, which, fun fact, despite the name, is actually a highly interactive sandbox for writing code and testing your data outputs in real time. Let's move to part 4 and see how this builds. Engineering AI with ML and Gen AI. We are leaping into the highly technical engineering roles powering today's AI boom. Look, models are great, but someone actually has to build the infrastructure to make them run in the real world, right? Meet the ML engineer, or the builder. As you can see, their skill set is absolutely massive. They combine machine learning with heavy-duty data engineering. They build ETL, that's extract, transform, load pipelines, and they master MLOps to keep models running continuously in production. To actually pull this off, they deploy complex distributed systems using tools like Spark, Hadoop, Airflow, Kubernetes, and Docker. They aren't just creating the model, they are literally building the factory that runs it at scale. Finally, we arrive at the absolute bleeding edge of tech, the Gen AI engineer. This is the pioneer. Now, their core skills revolve around LLMs, large language models, but equally important is RAG, or Retrieval Augmented Generation. I know those are intimidating acronyms, but RAG basically just bridges the gap between a model's internal memory and external real-time factual databases. It empowers you by grounding the AI in actual facts. So the crucial point here is that working with massive GenAI models requires a totally unique set of skills. Beyond just understanding models and RAG, a GenAI engineer has to be a master of prompt engineering, literally shaping the exact context the AI needs to generate the right output. They handle really complex API integrations, and critically, they enforce rigorous evaluation and bias mitigation. They have to ensure these models actually behave safely and fairly out in the wild. Because their skills are just so specific, this cutting-edge toolkit diverges completely from what a standard data scientist uses. Yes, they still use heavy machine learning frameworks like PyTorch and TensorFlow, but they also rely heavily on Python transformers, specialized platforms like Hugging Face, application frameworks like LangChain, and entirely new infrastructure like vector databases. And vector databases are wild. They store information as mathematical concepts rather than just your standard rows and columns. It's a highly specialized, rapidly evolving world for sure.
And that brings us to our final section, finding your perfect role.
We've climbed the entire tech ladder, and now it's time to reflect on which rung actually fits your own strengths. Think about the arc we just traveled, from the foundational communication and requirements gathering of the business analyst, to looking back in time with the SQL-wielding data analyst, then forecasting the future with the statistical modeling of the data scientist, building the heavy infrastructure with the ML engineer, and finally reaching the absolute frontier with the GenAI engineer and their vector databases. Every single one of these roles is incredibly vital. It's really just a matter of choosing your path. But as we wrap up this explainer, I want to leave you with one final provocative question. We've clearly defined the boundaries between these 5 careers today. But as tools become smarter and AI continues to evolve at a breakneck pace, will these distinct roles eventually just merge into one massive super role in the future? It's definitely something to think about. Thank you so much for joining me to decode the data landscape today, and as always, keep exploring.